we're going to look at numbers just like these, fractions, 1 divided by 2. We're going to focus on what they are and how we use them.
And here's one of the ways that I'm going to use the fraction. I'm going to take a candy bar, and I'm going to divide the candy bar into 2 equal parts. And then each one of those parts is equal to 1/2. I've done it one way, and I can do it another way. This time I've divided the candy bar a little bit differently, but I still have 2 equal parts, and each one is equal to 1/2.
The important thing is that we have the same unit divided into equal parts, and that gives us the fraction 1/2.
Let's go over to the number line using a mathematical tool to explain the fractions.
Our number line here represents a unit from 0 to 1, just like a whole candy bar. Here's 0 to 1. It's been divided here to create 2 equal portions, just like the 2 equal portions of the candy bar. This is 1/2, and this is 1/2. Together, that's 2 halves, or 1 whole.
And I have the same portion of the number line divided into 3 equal parts. Each one of these is equal to 1/3, so that I have 1/3, 2/3, and 3/3.
We could continue in that same fashion and take that same unit length and divide it into even greater number of parts, like 4. Here we have 4 equal parts dividing this unit up, and these are called fourths. Here's 1/4. This one makes 2/4. We add this one on, and we have 3/4, and of course 1 whole is 4/4.
There are 2 special words that we use when we talk about fractions. Those words are denominator and numerator. The denominator refers to the bottom number, and the bottom number tells us how many parts we've divided the whole into. The top number is the numerator, and that tells us how many of those parts we're talking about. Over here, for example, with 3/4, we're talking about 3 of 4 equal parts.
And since we have taken the same unit of length and divided it into first halves, and then thirds, and then fourths, we can compare the size of 1/2, 1/3, and 1/4. And it's very clear by using these number lines that 1/2 is greater than 1/3 of the same unit, and that's greater than 1/4 of the same unit. Another way of saying that as we divide it into more and more equal parts, each of those parts are going to be smaller.
And another thing we can point out on the number line, over here at 1, with the first part here, we had that divided into 2 halves. Here, we had it so that we had 3/3. Again, it's 1, and we have it divided into 4/4. It makes sense, really, because 2 halves means 2 divided by 2, and that's 1. And 3/3 is 3 divided by 3, and that's 1, and so forth.
And so on. Just like all numbers, there are some numbers that are equal. Fractions are numbers, and if we move this one down here, it's very evident to us that the fraction 1/2 and the fraction 2/4 represent the same number, just written in 2 different ways.
Different names for the same number.
Right. Now, if we look at what we have here, they're just numbers with no labels on them. And without labels, the numbers really don't have too much meaning. When we put labels on our numbers, then we're talking about objects that we see and have understanding. For example, if we look at this, we have a quarter. Well, we recognize this as 1/4 of a dollar. A quarter and 1/4 being the same term for that fraction 1 divided by 4. Well, 1/4 of a dollar is different than 1/4 of an hour. We know that this means 25 cents. We know that 1/4 of an hour means 15 minutes. So there's examples of fractions that seem the same, but because they have different labels, are very different. 1/4 of an hour and 1/4 of a dollar are not the same.
All right, here we have a situation where we do have the same label, pizzas. And I have a half of a pizza.
And I have half of a pizza.
But they're not the same.
Well, we have to be sure that we're taking half of that same amount.
That's right.
My pizza is obviously smaller, so half of a smaller amount is going to be less than that half.
Right. And another thing that we can point out with the pizzas is I can draw an imaginary line here, and we would then have 4 equal parts. And we can easily see that 2/4 over there are equal to 1/2.
Just like we saw on the number line where they fit together, that 2/4 and 1/2 represent the same number as long as they're taken of the same object.
The same whole. And we use fractions another way. We talk about fractions referring to groups of things. I have a group of cookies, and there are 32 cookies here, and they have been divided into 4 equal parts, so that each one of these is 1/4 of the set of 32 cookies. I have 8 cookies here. 1/4 of 32 is 8.
In the same way, we have this set of cookies, which is obviously divided into 3 equal portions by their colors, pink, gold, and brown. Now, these are equal parts, or thirds. It just so happens that there are 7 cookies in each of these thirds. We have a set of cookies that's divided into 3s, which happens to turn out to be 7 in this case.
Okay.
So we've looked at fractions to find out that they're nothing more than numbers that present to us a division problem. The numerator divided by the denominator. And without labels, they really don't have a lot of meaning. As soon as we attach a label to it, we can understand what that fraction means. We have a recipe, and we need to increase the recipe. What that means is that we're going to have to add fractions. And in this segment, that's what we want to look at, addition and subtraction of fractions. What we need to remember is that fractions are just like any other number. They just have special labels. Let's look at this rod that's on the table. This rod has been divided into 4 equal parts. Well, we know when we divide into 4 equal parts, we now can call these fourths. So if we put them together, we end up with our entire rod. What we have done is we've created the addition problem. 1/4 plus 1/4 plus 1/4 plus 1/4 equals 4/4, which we know is the same as 1. In the same way, we could create a subtraction problem. We could take these 4/4 and take 1 away. 4/4 minus 1/4 is equal to 3/4. Now, the examples that we've used are not that important, but what is important is the concept that we've used, that it's just the label that we are using that makes the problem any different. Let's look at some other examples of objects that usually appear in fractional parts, although we ordinarily call them pieces, but they're fractional parts just the same, and let's go through some other questions here. Here we have this chocolate bar that's been divided into 2 equal parts. We could think of that as a half plus a half, because 2 equal parts make the whole. This chocolate bar has been divided into 4 equal parts. So, like the rod before it, these are fourths. And we could think of 1/4 plus 1/4 plus 1/4 plus 1/4 equals that whole chocolate bar, or 4/4. This final chocolate bar has been divided into 3 equal parts, or thirds. And in the same way, we could add each of these thirds together, a third plus a third plus a third, and again, we're back to the whole candy bar, 3/3. Simple addition of fractions. The important thing to remember is that they were labeled differently. These were halves, these were fourths, and these were thirds. It's the label that allows us to just go ahead and put the numbers together. Well, we often see pizzas divided up in this fashion, and you see we have 4 equal parts. They're called fourths. Just like when we subtracted before, if we take away 1/4 from 4/4, we have 3/4. Again, the label here is fourths. If we look at this pizza, we see that we have it divided in half, and we also see that there's an indication that it could have been divided into fourths. Well, let's subtract half from this. If we do, we're left with half. What this tells us is that 2/4 and 1/2 are the same, something we already know. If we reverse that process, or add the half back in, well, 1/2 plus 1/2 is the whole again. So what we've seen is that addition and subtraction of fractions is no different than addition and subtraction of any other numbers, that the fractional parts are just special labels. If we were to take 2 chairs and add 5 chairs, we'd have 7 chairs. If we take 2/9 and add 5/9, we have 7/9. Addition of fractions and addition of numbers, the same. Subtraction of fractions, subtraction of numbers, the same. Why? Because fractions are nothing more than numbers with special labels.
We've had a real good year of lobster fishing this year. We like to set our traps from 10 feet to 10 fathoms. That's 60 feet. They're 6 feet to a fathom. We also have a legal limit on the size of the lobster that we can take. They have to be at least 3 3/16 from the back of the eye to the back of the hard body. And they can't be any more than 5 inches from the back of the eye to the back of the hard body. Now this fellow right here is 3 3/4 inches, and he'll make a real nice meal for somebody.
The saw blade is 1/8 of an inch wide. In making your measurements and your cuts, you always need to stay on the right side of your line or the outside of your measurement. If you don't do this and cut on the left side of the line, you're going to be 1/8 of an inch short. Perfect.
You would think with 5 sisters owning this restaurant, I would only have to do 1/5 of the work. But it's not that way for me.
My recipes come out of just everyday cookbooks. For instance, my refrigerator roll recipe probably made 40 rolls, but in this restaurant I need 60 rolls a day. I have found out through the patterns of how many customers come in. So I take the recipe and I times it by 1.5. So now instead of using 1 cup of shortening, I'm using 1.5 cups of shortening. Instead of using 1/2 a cup of sugar, I'm using 3/4 a cup of sugar. Instead of using 1 tablespoon of salt, I'm using 1.5 tablespoons of salt. Instead of using 2 eggs, I'm using 3 eggs. Instead of using 2 packages of yeast, I'm using 3 packages of yeast. And that's a way that fractions help me all the time.
The other day I had a pizza party at my house. I invited a few friends and ordered 2 pizzas. As soon as it arrived, my hungriest guest came and helped himself to 1/4 of a pizza. When he removed his piece, he subtracted 1/4 from 2. How much does that leave? The answer is easy. When we subtract a fraction from a whole number, we convert the whole number into a mixed number with the same denominator as the fraction being subtracted. Since 1 whole pizza is the same as 4/4, he had subtracted 1/4 from 1 4/4. As you can see, that left 1 pizza and 3/4. My friend Linda is on a diet, so she only took a small piece, about 1/8 of a pizza. So now how much is left? Well, the math, again, is easy. We have to make the denominators the same first. In this case, 3/4 is the same as 6/8. And then we can subtract 1/8 of a pizza from 1 6/8, leaving us with 1 5/8 pizzas. I still had a lot of pizza left, and I started to worry that it wouldn't all be eaten. I didn't have to be concerned for long because my husband offered to bring some to his friends in the other room. He thought they would need about 3/4 of a pizza just for themselves. Since I had a couple of friends who hadn't eaten yet, I didn't know if I should let them take so much. In order to figure out how much would be left, we have to first convert 3/4 to a common denominator. So we had to think of the 3/4 as 6/8. Now we can't subtract 6/8 from 5/8. So we have to think of the whole pizza as 8 pieces. We can restate the subtraction problem as 13/8 minus 6/8, leaving us with 7/8. Just enough for me and my friends. So you've seen that when we subtract fractions, we have to convert whole numbers to fractions with common denominators before we can perform the subtraction. Once we do this, it's really pretty easy.